transform, Laplace, Fourier sine, cosine, jet transformation, Hankel transformation, and their inverse transformation, and also there are some properties, convolution, and application based on these. How to show these fractional means differential and difference equation. Okay, this is the integral transform, and second part is perturbation methods. Basically, it is the perturbation theory, and in which we will discuss regular perturbation theory, singular perturbation theory, and asymptotic matching like this way. Okay, and in the third part, it is the calculus of variation CV. Okay, and it contains the introduction, variation problem with functionals here, and containing first order derivative, Euler equations, functional containing higher order derivative. So you know these words you have listened before. What is the derivative? What is the differential equation? Okay, this differential and difference equation, and several independent variable problem with moving boundary conditions, boundaries with constants, higher order necessary conditions, various stress function, Legendre and Jacobi's condition, existence of the solution of variational problem. Okay, existence of the solution of variational problem, and Rayleigh this method statement of Ackland variational principle, in which there is a self-adjoint, normal, and unitary operators. Okay, and in the last section we have an integral equation. Okay, and in which we will discuss here linear integral equation. Okay, the content of this integral equation has classification of the integral equations, classification of integral equations, Newman's iterative methods for Fredholm equations of second kind, Volterra type integral equation of first kind, and it is Volterra type, and convolution type integral equation. Also you have seen that convolution is also discussed there, this one, convolution theorem. Okay, and also non-linear Volterra equations and Hilbert-Smith theory. Okay, so this is the syllabus in mathematical methods. Okay, and we recommended some books, and also you can note these books. Okay, in which you can find all the topics of relevant contents. Okay, so recommended book is FB Hildebrand, Method of Applied Mathematics, Tom Apostol, Mathematical Analysis, Rudin, Principle of Mathematical Analysis, A.S. Gupta, Calculus of Variation, and F.G., Integral Equation, and also M. Rai Singhania, Integral Equation and Boundary Value Problem. Okay, so generally for the integral equation, we recommended this book. Okay, M. Rai Singhania, Integral Equation and Boundary Value Problem. Okay, you can download this book, this or others book. You can download all the books from the Google net. Okay, so I think syllabus is clear for mathematical methods. Okay, now, and you have seen that in the syllabus, what sir means in the integral equation we have used there is some properties of like this way, and to show the differential and difference equation, first order derivative. Okay, you know, so first of all, basically mathematical methods is based on the integration and differentiation, means it is the mathematical method is based on the calculus. Okay, and basically calculus is a subject which in which we study the differentiation and integration of various type of functions. Okay, so here, so now before going to start the integral equation, okay, first we will start from this topic, integral equation. Okay, we will start from integral equation. Okay, so before going to start linear integral equation, we have some reviews, means we will discuss some basic terminology of calculus. Okay, and okay, now first topic is a review of initial. What do you mean by initial? It is also called IVP, initial value problem, and boundary value problem, BVP. Okay, initial value problem and boundary value problem. Okay, what is these problems? Okay, so what's our initial value problem and what's our boundary value problems? Okay, suppose we have a differential equation of order m. Do you know what is the order n of a differential equation? What is the order of differential equation? What is the order of differential equation?
कितने
Highest
टाइम
derivative.
डिफरेंशिएशन हुआ है?
Highest order derivative.
Highest. Yes.
यस.
Okay, that will be the order of a differential equation. Suppose we have a m order differential equation and a general form of m order differential equation like this way, and you can see that it's here y is a dependent variable and x is a independent variable. Okay, y is dependent variable and x is independent variable. So it means that here y, suppose y is a function from, we can take any interval to r like this way. Okay, so here, and y is a function from interval to any set of r, and dy d to the power my upon dx to the power m is represent the mth order derivative of y. Okay, and you can see it is a m minus 1th order derivative of y, and here a1x a2x up to all, here these may be the function of x, and also maybe they may be constant. Okay, so the general solution of above equation, because its order is m. Okay, the general solution, and you know what is, how many types of differential equations, how many types of solution exist for differential equation. Okay, so basically for the general solutions of mth order differential equations, okay, we need m constant. Do you agree this? For the general solution, suppose here, for the general solutions of m order differential equation, suppose if I take here y double prime is equal to y here, so its solution will be like, what is the solution of this? M square equal to 1, so m equal to plus minus 1, then its solution is will be e to the power x plus c to e to the power minus x. Okay, so it is the solution yx is equal to this one. So basically it is a general solution of this differential equation. Okay, are you getting my point?
Yes, sir.
यस सर.
Okay, okay, so means if we have a second order derivative, then you can see that the solution of this differential equation contains two arbitrary constant. If the order of the differential equation is m, it means that that general solution which contains m arbitrary constant. Do you agree this?
Yes, sir.
Okay, so we have m constant due to the m order of differential equation. So to find the particular solutions, to find the particular solution of above differential equation, this differential equation, we need m conditions. Do you agree this? We need m conditions, because we have mth order derivative. Okay, to find the particular solutions, we need m conditions. Do you agree? So these m conditions, we need m conditions to find the particular solutions of the general solutions. Okay, so based on these m conditions, we can divide these conditions into two parts. Okay, so first condition is called initial value condition, initial condition, and second is called boundary condition. So basically, what's our initial condition and what's our boundary condition? Okay, so here, if all m conditions, because we need m conditions to find the particular solution of this differential equation. Okay, if all m conditions are prescribed at single point, here you can see that here a single point. Okay, for example, here it is a second order differential equation, and suppose the condition is given here y 0 is suppose 1 and y, because we need two conditions, it is second order. So suppose v prime 0 is equal to suppose 0, so you can see that this is the point at which the function is defined, and okay, it is also a point here at which the first order derivative is defined. So basically these are the conditions, these are the points, and these points are single points. It is 0, it is 0 also. Okay, so if all the conditions are prescribed at a single point, suppose x equal to x naught, then that differential equation is called the IVP, initial value problem. Okay, and the conditions are called the initial conditions. Is it clear? It is clear?
Yes, sir.
Okay, now we move the boundary conditions, and it means to find the particular solution we need m conditions. Okay, we need m conditions, and we have seen that y is a function from any interval to r. Y is a function from any interval to r, a, b. Okay, and if the required condition are prescribed 2 points, in this case it is single points, and in this case it is 2 points. Okay, if required condition are prescribed at 2 points, say x equal to a and x equal to b. Okay, these are m conditions. Okay, some conditions are defined at x equal to a, and remaining conditions will be defined at x equal to b. Okay, we have 2 points here. Then the differential equation is called boundary value problem. Together with this is called boundary value problem, BVP. And these conditions are called the boundary conditions. Okay, do you agree this?
Yes, sir.
Now you can see here one example. Also I have taken here, it is a second order differential equation. It is given y double prime plus 9y equal to 0, and here, because it is second order differential equation, to find the particular solution of this differential equation we need two conditions, first condition and it is second condition, and you can see that first condition is defined at 0. Do you agree? And also second condition is defined at 0. So all two conditions is defined on single points. So this is the initial value problem. Okay, do you agree this?
Yes, sir. Yes, sir.
Okay, now come to the second example. It is y double prime plus 3y prime plus 2y equal to x here, and you can see that here dy upon dx, y is a function from an interval to r. Okay, so basically y prime is nothing, it is dy upon dx. Okay, and y double prime is nothing, it is d square y upon dx square, means y is a function of x here. Okay, y is a function of x which is defined from ab to r. Do you agree? And in this case you can see here this is the second order differential equation. So to find the particular solution we need two conditions. We need two conditions. So this one is the first condition and this one is the second condition. Do you agree this? And you can see that first condition is defined at 0 and second condition is defined at 1. So here 0 and 1 both are distinct. Okay, means these are different. Okay, so it means that this differential equation, this second order differential equation is BVP, boundary value problem. Can I move another
Yes,
slide?
sir.
Okay, it is clear. Okay, Okay, now we move the a journal initial value problem here. Okay, suppose we have a journal IVP. Okay, suppose I take first order initial value problem. First order means its derivative dy upon dx here is 1. Okay, dy upon dx is equal to f is a function from xy, and here y at x naught is y naught, and x is nothing, it is defined here interval x naught to x1. So we can say that here y is a function from x naught to x1 to r. Do you agree this? Okay, so it means that it is an initial value problem. It is the journal initial value problem. Okay, so here, what is the solution of this initial value problem? So basically, that function y, will be a solution of initial value problem. This if first condition is that function y from x naught to r such that y must be belongs to this class. Okay, basically is a class of functions. That class of function is called continuously differentiable function. Continuously differentiable function means functions are differentiable and continuous. Okay, continuously differentiable function. Okay, it is a class of continuously differentiable means functions are differentiable and these are continuous, means derivative is continuous. Okay, if this function y, which is defined like this way, function y from this closed interval to r, such that this function is belongs to this class, means continuously differentiable function. If y is a continuously differentiable function, okay, then that function is called the solution of 1. 1 means this initial value problem on the interval if and only if y is a solution of following integral equation. Okay, so basically y is a solution of following integral equation. So what is this equation? Okay, so it means that I'm saying that y is a solution of this initial value problem if and only if y is a solution of this integral equation. Okay, so condition is that y must be belongs to C1 class. Okay, do you agree this? The proof of this result is very obvious. So how to find this equation from the initial value problem? Just what will you do? We will take the integral. Okay, integrating dy upon dx equal to fx with respect to x over the limit x naught to x. Okay, so what we do means just when we take the integral, then you will obtain here dy upon dx limit x naught to x, and with respect to dx is equal to integrating x naught to x function of x. Here in place I can write here y into dt. Do you agree this? So basically it is nothing. So we can write here y because derivative and integral will be here, and it is here x naught to x is equal to x naught to x integral of t into y into dt. Also we can write, okay, substituting the value of, when we substitute this value, y we will obtain here yx minus yx naught and equal to this quantity here, and we shift this quantity into right hand side, we will obtain this integral equation because the value of y naught is here. It is y naught is y naught. Do you agree this? Any doubt?
Yeah,
No. Okay, so means from initial value problem we can convert this initial value problem into the integral equation. Okay, so basically it is a integral equation. Okay, so from this integral equation we can convert this integral equation to the initial value problem. What will you do? Just we will take the we will differentiate this equation with respect to x, and using the Leibniz rule, then we will obtain this differential equation. Okay, so here we will use Leibniz rule. So we will discuss all this rule in the coming discussion. Okay. Any doubt till now? Any doubt? Okay. So now we move. So basically, it is nothing. It is an integral equation, and this integral is obtained from the initial value problem. Same here. If we have a boundary value problem, the boundary value problem can be converted into the integral equation also. Okay, means initial value problem also can be converted into the integral equation, and boundary value problem. If we have boundary value problems, then we can convert this boundary value problem into the integral equations. Okay, so this is nothing. It is an integral equation. Do you agree this? It is integral equation. Now we will discuss this integral equation. Okay. So we will take a general form of this integral equation. Okay. So first of all, we will discuss, we will define what is the integral equation here. Okay. So an integral equation is an equation in which a known function, here we have a known function, in which a known function appears under one or more integral sign. Do you agree? This is the definition of integral equation. Okay. For example, definition is clear. Means an equation is called the integral equation in which a known function appear under the one or more integral sign. Okay. So here why is non-function? We have to calculate this. Why is a non-function? We have to calculate this one. Why is the solution is differential equation? Also, we can why is the solution of this integral equation? If y satisfied this integral equation, also we can say that y is the solution of this differential equation. If y satisfied this differential equation, do you agree with this? Here y is a non-function. Okay. Now we have some examples. Okay, we have some integral equations, and you can see that here fx is equal to, suppose x lie between any interval, that interval is a to b, and zeta is also belongs to that interval will be same here, and it is given here fx equal to a to the power x k x zeta u zeta d zeta. Okay, this is a one type of integral equation. There are two functions. One function is here and second function is here. Do you agree this? An equation in which unknown function. So what is the unknown function in this? But there are two functions. There are two functions which are appear under the integral sign. Okay. U x plus lambda x is equal to a to b. See here, here it is here, but in this it is a to b, where x is a to b, and zeta is also to that to is and so these are two functions. Is non-function. Okay, so here you have to calculate value of ux, that will be the solution of these integral equations. Okay, here ux is a noun function. Okay, while these fx and kxt, these are the noun function. Okay, here k is a noun function, and lambda a and b are constants. These are the constant a to b and lambda, these are constant, are all are constant. Okay, are all complex valued function. Do you agree? Means here ux, fx and k all are complex valued function, but the x and t are real variable, variables. X and t are real variable. Can you write? Means like this way. Suppose if I write here u is a function from interval ab to r here. So I can write in place of r, we can write here c. Then we can write here ut is equal to suppose at plus ibt. Okay, so here ux, fx and kf may these are the known functions and they may be complex valued function, and here t is real valued function. Okay, t and x are real variable. It is clear?
सर एक बार फिर समझा दिए थोड़ा सा लास्ट पोर्शन.
Okay, so basically in place of t, it is zeta. First of all, I have some typo error. I am saying that suppose we have some integral equations here. Fx is equal to a to x kx zeta u zeta d zeta, and you can see that under the integral signs there are two functions k and u. Same here. Here ux is equal to fx plus lambda a to x k and u. Again there are two functions in the integral sign. Okay, ux equal to this quantity a to b k x zeta and u zeta whole square d zeta. So you can see that under the integral signs there are two functions. There are two functions. Do you agree this? Under the integral signs we have two functions k and u, in which here u is the unknown functions. Unknown functions means we have to calculate ux from these all integral equations. Basically u is nothing, u is a solution of this integral equation, which means u is a function, and that function is called the solution of integral equation corresponding means these integral equation if u satisfy these integral equations. Okay, so here u is a unknown functions, we have to calculate u. U is a unknown function while k and fx all are known functions, and lambda ab are the constant, and also these functions u, f and k, these are complex valued functions in which x and zeta are the real variables. Like this way, suppose u is defined like this way, a to b into c. So we can define ut equal to a t plus ibt. Okay, here u is a complex valued function, but t is a real variable. Do you agree this? Any doubt? Any doubt?
No, sir.
No. Okay. So today I stop here. Okay. From tomorrow we will
Sir.
start. Yes.
सर ये वाली स्लाइड शेयर कर देंगे क्या?
Slides. शेयर कर सकते हैं? कोई ऑप्शन तो नहीं है इसमें शेयर करने का? I will mail. Okay.
Okay, sir.
Okay, I will mail. Okay. Now, please wait. I'm making your attendance. Roll number are, you know about the roll numbers. Okay. 1, 2, 3, 4, 5, 6,
Yes, sir.
7,
Yes, sir.
8,
Yes, sir.
9, 10,
Present, sir.
11, 12,
Yes, sir.
13, 14, 15, 16, 17, 18,
Present, sir.
19, 20, 21,
Present, sir.
22, 23,
Yes, sir.
Yes, sir.
23.
Sir, 23.
Okay. 24,
Present, sir.
25,
Present, sir.
26, 27,
Present, sir.
28,
Yes, sir.
29. Thirty, 31, 31,
Yes, sir. 31. Yes, sir.
32, 33,
Yes, sir. Sir, sir, 33.
34, 35,
Yes, sir.
36,
Present, sir.
37, 38, 39,
Present, sir.
40,
Yes, sir.
41, 42,
Yes, sir.
42, 43, 44, and 45.
Yes, sir.
Sir. 45 present, sir.
Okay.
Sir, 44.
44. Yes. Juba.
45, sir.
Yes, yes, sir. I mentioned.
Yes, sir.
Yes. Roll number 11.
Sir, roll number 1.
Roll number 11 is Arvind Kumar. 13, yes.
सर सत्यम राय एक बार कंफर्म कर दीजिए 30 और 41 इसी में से।
Sir, roll 1 कर दीजिए.
Wait. Roll 1 is present here.
Sir, roll number 2.
41 is present.
41 सत्यम
Yes,
राय
sir.
या
Yes, sir.
कोई और
41, sir.
is Suman Dev.
Yes, sir. Yes, sir.
सर सत्यम राय 30 होगा तब
सर सर रोल नंबर
सर
9 लगा
सत्यम
दीजिए।
राय
Satyam Rai is
Satyam Rai.
30.
ओके सर थैंक यू
सर रोल नंबर 9।
Roll number 9. 9 is Anubhav.
Yes, sir.
Sir, roll number 2.
2. Akansha.
Yes, sir.
Okay. Any other students? No. Okay.